Thank you all for coming. Welcome to lecture 5 of our course. I hope you're enjoying the course so far. Last lecture I wanted to do, but I couldn't because I had a flu and I couldn't really speak. This week it's much better. I think Tanush did a very good job doing the last lecture. This lecture today will be on computer vision. The lecture itself will be a bit more dry because we have a bit less quizzes, a bit less programming or live programming, but we need to go through some of the basic elements, and then afterwards we have the tutorial where you are able to put all these elements together and actually program yourself. So these were the main challenges for computer vision for a very long time, essentially until 2012, where the convolutional neural networks came up. So what I want to do now in the lecture is basically talk to you about the 4 main ingredients of convolutional neural networks. It's a bit dry because they only work if you put all of them together, and you will put them together in the assignment. But the first one, I think, on the other hand, is also a bit visual because, hey, we're talking about images. We can look at images, and we have very good perception. So for us, it's to some extent also understandable. And these filters are most important, essentially. And why are they important? Because they help the computers to actually do this differentiation. And the key idea is to not look at the whole picture at once, but to think about ways how we can extract features from images. And features may be very different, but for example, for faces or for humans, it may be an eye, right? So if I, as a human, see that, like an eye from you, I know you're human. It's very easy for me, right? Or if I see a nose, I know you're human, because cars don't have that, right? Cars don't have eyes, cars don't have nose, and so on. And same for the cars, right? So there's quite a few distinct features that help me to differentiate a car from a human and from other objects as well. So one of the goals in computer vision is to think about ways how we can extract those features from images. And first of all, we will discuss that manually. So how can we build features or filters that can extract these features? But later on, the convolutional neural networks will learn automatically how to do that job. And if you think a bit about it, usually there's some kind of abstraction process. So you have some kind of high-level features, which might be a face of a human. And then you have mid-level features. That's the eye, the ear, the nose. But there's also very low-level features. And that could be a line or a dark spot or something like that, right? And maybe these ones here don't help you now to identify if that's a human or a car. But that really depends on the context, on the supervision task, or on the learning task that you have. So usually you go from here to here to here in order to extract information. So the question is, how can we get there? So how can we get these features out of images? And the key idea is filters. So what do filters do? Filters are basically matrix operations that are applied to the whole image. So there are mathematical operations that go through the image and create a feature map. And feature map is this new image that we generate. And what you see in this lecture and also in the literature is that there's different nomenclatures that we use. So if we talk about convolutions, kernels, or filters, usually we always mean the same. It's just different communities speaking about the same thing. So convolutions, we usually use this in the deep learning context, whereas kernels and filters are a bit more from standard computer vision, so from before 2012. And I want to make one example. I think that's easiest to show. So we can consider this one an image, and very easy image. So it has 6 pixels on this side, 6 pixels on this side, and has only 2 values, so it's a grayscaled image. So all of this one is white, and here we have a black, black pixels essentially. And if you represent this one as a matrix, it will look like this one here. So we now define that 1 means white, 0 means black. So this one is a matrix representation of this beautiful image. And what we want to do is we want to apply a filter on this and see what it does. And a filter is usually also represented as a matrix. In this case here, we have a moving average filter. And what we essentially do is we say we apply this filter to that part of the image. So what we do is we calculate 1 times 1 over 9 plus 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 1 time 1 over 9 and so on. And we do that, and the result is 1. Why? Because it's essentially a moving average, right? So we calculate the average of these values here. And this goes to the middle of this one here. And then we move our filter 1 step to the right, and we repeat. So again, we take the average of all of this. This time it's 0.88. Why? Because, well, there's a 0 in here. We move it further and further until we put everything together here. So what we see is, by applying this filter, we make our image smaller, right? Because all of these values are empty. I'm actually not sure if this CC has a meaning. No, I think it was an error, sorry. We will delete that. And we can do that with a computer as well. And you can check the code later on. I don't do live programming here because it's relatively simple code. So what we have is we have the matrix here, which is this matrix. We have the filter here, which is this filter. And then we define the output, and we go through these convolutions through a for loop, or essentially through 2 for loops, because we go from left to right and from top to bottom. And then what we do is we create a patch, and the patch is essentially, I'm not sure, this one is a patch here, so that's a relevant part. Why do we do that? Because, well, we process a patch together with a moving average in order to create that value. And then once we have that patch, we need to multiply it, takes a sum over all values, and that's essentially it. So that's one very simple way how we can implement that in Python. And you will do that later on in your assignment or tutorial as well. And if you do that in your tutorial, you may want to take a look at the actual math formula. So we put it here on the slides. I don't want to go into detail. It's a relatively simple, multiplication and summation. It looks a bit scary, but it's possible to implement. So don't worry too much about it. And we can also apply this to real images, right? So we took here a logo of our group, and I'm not sure if you can recognize it, but there's a bit of noise here that we added, right? That could be from an old image that you get from your grandpa, you scan, right? So maybe it's not the quality as from your new iPhone. If you apply this average filter, what basically happens is it will, look at a small part here and take an average. And then what you see is all these pixel values will average out essentially, right? So it's a bit of a smoothing effect you see here. And if you look very carefully, well, these are not as intense, but then also this one is not as sharp as it used to be. So this filter is, useful for making images a bit smoother. And